Rouletteology. Power to get wealth. That power belongs to God. Is literally in reality fishing for money. Roulette trilogy, tripartite schema selection process of elimination, opposite election common principle. A vertical, horizontal, and lateral penta chips line bet, the perfect precise smartest bet in the planet roulette. The Lord be magnified which hath pleasure in the prosperity of his servant. Which teacheth thee to profit, which teacheth thee in the way that thou shouldest go. And make thee rich. Law of reverse gambling, exclusively for the spiritually mature, well-trained and fully equipped disciplined being born again Christian. Now concerning spiritual warfare, revealing the law of reverse gambling. A satanic onslaught on the book of Numbers of 36 chapters. Is the will and the table of 36 numbers. The sum of 1 to 36, be as it may chapters or numbers is 666. The total opposition to God. I say it 52 weeks in a year and 7 days a week Isaiah 52:7. How beautiful upon the mountains are the feet of him that bringeth good tidings, that publisheth peace, that bringeth good tidings of good, that publisheth salvation, that saith unto Zion, thy God reigneth.
Thank you to all of you for coming along. Now, as Tom mentioned, I'm a researcher at the London School of Hygiene and Tropical Medicine, where I specialise in mathematical models of infectious disease. So on the face of it, my job couldn't be further really from the world of casinos and playing cards and plastic chips, but really science and gambling have an incredibly intertwined relationship, a really long-standing history, and that's what I want to talk about. And the reason I wanted to show you this is I think when we talk about people taming chance and beating the system, typically these are two themes that crop up quite a lot. You either have them doing something a bit dodgy, or you have them presenting a system which clearly isn't going to do something very successful. Take a look at some of the ways in which mathematicians and scientists have taken on games of chance and used their techniques to get an edge over the house. I also want to look at how the ideas have flowed the other way, how actually games and gambling have inspired many ideas which are now fundamental to modern maths and science. Although maths has been around for millennia, the idea of how we quantify luck, how we quantify a random event, is just a fantastic illustration of how you can take a pretty simple mathematical insight, a good dose of audacity and hard work, and convert it into something that's profitable. And really, this story is representative of a lot of areas of gambling. Often it's not professional gamblers who come up with these strategies that beat the system. And often people who beat the system don't become professional gamblers. For a lot of these people, gambling is almost a playground for ideas. It's a way of testing out problem solving and skills that actually will apply to many other industries. People who target these problems moved into academia, into finance, into business. And this isn't a new phenomenon. Really, throughout history, many of the great thinkers and mathematicians have used gambling as a way of refining their ideas. And in around 1900, a French mathematician called Henri Poincaré was particularly interested in gambling. Now, Poincaré was interested in was predictability. And to him, unexpected events, unexpected outcomes were the result of ignorance. He thought, if something's unexpected, it's because we're ignorant of the causes. And he classed these problems by what he called the 3 levels of ignorance. The top level was a situation where we know what the rules are, we have the information, we just have to do some basic calculations. So if you've got, say, a school physics exam, you know what the physical laws are, you're given the information, so, in theory, you should be able to get the right answer. If the answer's surprising, then you've done something wrong in the working. But it's not a kind of difficult level of ignorance to escape, in theory. The second level of ignorance, according to Poincaré, was one where you know what the rules are, but you lack the information necessary to carry out the calculations accurately. And he used roulette as an example. So a roulette table, you start a ball spinning round and round, and he observed that a very small change in the initial speed of the ball could have a very dramatic effect on where it ends up, because it's going to be circulating this table over time. And then we'll say that the result is random, it's down to chance, but really it's a problem of information. Then comes the third degree of ignorance, and this is where we don't know the rules, or perhaps they're so complex we'll never be able to untangle them. And in this situation, all we can do is watch over time and try and gain some understanding of what we're observing. And it was really this level of ignorance when gamblers started targeting roulette that they focused on. They didn't try and untangle all of these physical laws. They just said, well, let's just watch a load of roulette spins at the table and see if there's a bias, see if there's something odd. And he was also interested in roulette. Now, fortunately for him, at the time, the Le Monaco newspaper would publish the results of all the roulette spins in the casinos of Monte Carlo. Now, for Pearson, this is a fantastic data set. He wants to test out these ideas about randomness. You've got all these previous roulette spins to test it out on. And he started looking at ways to understand whether they were random or not. And roulette table, of course, you've got these black and red numbers, and then you've got a zero. If you take out the zero, over time, you'd expect the proportion of black and red to be even. You'd expect it to kind of be 50-50 over time. And when Pearson looked at the data, he found that red came up 50.15% of the time. This was over about 16,000 spins. So according to his calculation, this wasn't that implausible. That actually that kind of deviation from the expected value is reasonable given the kind of data set he had. But then he continued and he looked, for instance, at how often pairs of numbers appear. Now, if you've got a random process, a roulette table, sometimes you'd expect there to be a string of the same colour appearing purely by chance. You might get a few reds coming up, a few blacks. But what Pearson found was that the numbers switched too often. That actually, you didn't get these strings of the same colour appearing as often as you might expect. They were kind of switching over. And to him, this was pretty definitive evidence that the tables were corrupt, that they were biased. And as he puts it, if I had been observing these tables since the start of geological time on Earth, I would not have expected to see a result that extreme. And he actually said, but this idea, think back to how he phrased it, that it was the probability of observing an event as extreme as the one I've observed. This was the first kind of forays into what's known as hypothesis testing. Nowadays, whether we work in clinical trials or on particle physics experiments, we use the principles that Pearson honed on these roulette tables and coin tosses to understand whether we have enough evidence to reject or accept a certain hypothesis. So in this case, his hypothesis was that the tables were random, and he had enough evidence to say that this wasn't the case. And actually, gamblers have also used these ideas throughout Victorian times and moving into late 1940s, for example, two medical students used these kind of methods to go, and unlike the lazy journalists, they actually watched the tables this time, collected all the data, and found that there were biases. These tables wore down over time, and certain numbers or areas would appear more often than not. And actually, they went around Nevada and gambled a lot of these tables, and the exact figure was never known, but they did buy a yacht and sail it around the Caribbean for a year, so a pretty successful strategy. In the 70s, a group of students at University of California, Santa Cruz, actually kind of started doing these calculations, and they looked at a roulette spin. They said, well, to start off with, the croupier would spin the ball, and it would go around the edge of the track, around the rim of the table. And often it would go around a couple of times before the croupier calls no more bets. In other words, you have a window in which you can collect information on what the ball's doing and act on it. You can place bets during this period. Over time, it would drop down onto the track and sort of spin freely. They eventually hit one of these deflectors and land in one of the pockets. And what they actually did, testing out their strategy on different tables in their lab, you write down these equations that calibrate them to a specific table. Then in that initial bit of time, you could collect enough information to improve your predictions about where the ball would land. You'd never get it exactly, but you didn't need to. You just need to get some idea of which region of the table it was going to land in, enough to get an edge over the casino. It's all well and good, of course, doing that in a classroom and working for all the equations, but in a casino, you need to do it in real time. You need to do that on the casino floor as the ball is spinning. So what these teams actually did was come up with hidden computers to do these calculations in person. Now, wearable technology is, of course, all around us these days, but the first wearable computer was designed for this purpose, as it happens. And because it was a new technology, there were, in New York state law, gambling is defined as anything that has a material element of chance. So if you think about this, it's a much narrower definition of gambling. It's not predominantly chance, it's anything with a material element, which clearly poker does have, and under this condition, it's defined as gambling. And this debate is ongoing if you look at fantasy sports in the US and a lot of these systems where do we have something that's luck, do we have something that's skill, where do we actually define these things as gambling? I think there's often a temptation, in fact, with the situation, to put things in boxes. We like to say there's a box with luck and there's a box with skill. I think typically if we're good at something, it goes in the box on the right. If we're bad at something, it goes in the box on the left. And that's really kind of tempting, but I don't think it's a realistic notion necessarily. I think particularly, through the history of how people have tackled games like roulette and with lotteries, it's much more of a spectrum. And actually games that we might think are the archetype of luck, things like roulette, actually if you have a skillful approach, you can tame that chance and you can convert it into some element of a game of skill. And even games that we might think are incredibly or almost solely developed skill, games like chess, can have surprising results of chance. In the 90s, famously, IBM's Deep Blue chess computer played Garry Kasparov. And during the match, in one of the early games, there was a situation where Deep Blue made a move that was so unexpected and almost kind of so subtle that it threw Kasparov a bit. And it by all accounts, convinced him that he was playing something that was just simply beyond what he was ever seen before. Just something completely beyond his capability. It turned out actually that what happened there is Deep Blue had run into a situation where it couldn't identify the best move. And in that situation, it had been programmed to pick randomly. So this set of games that is one of the landmarks in artificial intelligence over humans in a game that is thought to be purely skill was actually really kind of shaped by this chance event. And I think these kind of illustrations show why gambling and why these kind of games of chance are so important, because really whatever your views are of casinos and bookmakers, gambling is an inherent part of life. Betting is an inherent part of what we do, whether it's in health, in kind of prediction on this side, whether it's in business, whether in finance. We have to make decisions with hidden information. We have to deal with uncertainty. We have to balance the risks against the rewards. And I think that's why historically, so many researchers have been interested in gambling and continue to do so. Because really, if you want to understand luck and decision-making and risk, then arguably there's no way better to start than with a bet. So, thank you.
The dichotomy of gambling. The world thought of chance gambling. The word taught of certain gambling. It is certain, by no means is any win by chance. The lot is cast into the lap, but the whole disposing thereof is of the Lord. Proverbs 16:33. What's wrong with chance gambling? You don't always win. It's an erratic, whimsical, lucky gut feeling, wishful positive thinking. Or the spirit of fear. The law of reverse gambling thinks otherwise. You always win by means of certain gambling. It's an analytic, computed, calculated, correct thinking. Or the spirit of power, and of love, and of a sound mind. Thus, happening reversing gambling into blessing, to a very lucrative, profitable investing. Hence, the law of reverse gambling is blessing, godly spiritual profiteering.
Albert Einstein once said, "No one can possibly win at roulette unless he steals money from the table while the dealer isn't looking." So, if you're a young physics student in a casino with your best friend, absolute gambling rookies, how do you beat the house? You're out of your element.
12. Congratulations.
1975, herring plan is being hatched to beat the Las Vegas casinos. For the past several months, Norman Packard, a gifted physics student at Reed College, has become obsessed with the game of roulette. He is haunted by a single question. Could the physical properties of roulette be used to predict the outcome of any given spin?
The first order of business was just to study the roulette wheel and the ball and figure out whether or not there was enough predictability so that this project made sense.
Norman knows that to understand the dynamics of a specific roulette wheel, he'll first need to take a measurement of the ball's velocity as it makes its way around the rim. He heads to Las Vegas to gather his first data.
seems all very adventurous to actually go into the casino and see if the thing is going to work.
Norman comes up with an ingenious way to track the ball's velocity. As the ball spins around the roulette wheel, he tracks its motion by secretly tapping on a microphone every time it passes a fixed point.
As soon as you realize that there is this layer of predictability in the dynamics of the wheel and the ball, then that opens the door to having a possibility to beat the game.
By playing back the tape and measuring the time between the clicks, he can track not only the ball's velocity, but how the velocity decreases over the course of the spin.
I was interested in the intellectual interest of conquering randomness, or understanding exactly what the limits of randomness and predictability were.
Norman knows he has hit on something extraordinary. He also knows he has a lot of work to do before he can create a system to seriously beat the casinos. For this, he will need the help of someone with a scientific mind. Someone he can trust.
Nolan, you in there? Norman?
Doan Farmer is Norman's best friend from childhood and is just starting the graduate program in physics at the University of California at Santa Cruz.
Think about it, man. Everything we know about roulette is bound by the laws of physics.
I have to say, initially I was pretty skeptical about the whole thing,
Yeah, but there's friction and errors that can figure that out.
but then he started talking to me and ideas somehow took hold.
But what about when the ball hits those little diamonds? That happens less than 10% of the time. I checked it out. It's too complicated, Norman. It's classic Newtonian physics.
When Isaac Newton first published his laws of motion in 1687, he shed revolutionary new light on how moving bodies behave. These laws should define the outcome of any game with moving parts, even roulette.
I mapped it out. Here, look. The deceleration of the ball is consistent.
The results support Norman's theory. They seem to indicate that the motion of a roulette ball
It's not random.
is a pattern just waiting to be solved.
That's right. We can predict its motion just by using physics. I mean, imagine how much money we could make.
What do you say?
Say it's crazy. Let's do it.
Norman and I worked on some very wacky science projects when we were kids, but this is by far the most insane. And the most brilliant.
In order to predict where the ball will land, Doan and Norman need to calculate the timing of two events.
You see, when you look at roulette through the language of physics, it's the universe in miniature, a whirling, glittering mix of forces, all playing out a tiny, elegant dance. Cool.
Norman's initial research suggests that by scientifically tracking the ball, they might be able to predict where it'll land. While the prediction won't reveal an actual number, it may be accurate enough to predict a general area on the wheel that may come up. Their target is to be able to narrow their bets to a 1/8 slice of the wheel, an octet containing about 5 numbers. If they could do that, they could increase their odds by an incredible 750% and win a fortune. Might just come true if they succeed in creating a physics-based system to beat roulette. The spinning wheel has changed many fortunes. Any system designed to win at roulette was based on cheating until Doan and Norman come along. To beat the game with a physics-based system, Doan and Norman have their work cut out for them. First, they must select a specific wheel to analyze. Then, they must study the action of the ball on that wheel and write a set of equations predicting where it will land. And finally, find a way to make use of those equations inside an actual casino. But before they do anything, they need a professional casino-grade roulette wheel to experiment with. Doan and Norman make Santa Cruz their headquarters. Late at night, in the campus physics lab, Doan starts defining the steps to their first goal. Measuring the forces acting on a moving roulette ball. Doan and Norman have a long way to go. They must still quantify the movement of the ball, from the moment it leaves the croupier's hand to the moment it lands in the cup.
We spent a tremendous amount of time our first summer actually taking data.
We had this big thing we called the guillotine, which had the camera hanging over the roulette wheel.
I'll get back a little bit to the
left?
Yeah.
They rig a microphone which triggers the camera shutter exactly when the ball falls off the outer track. With each spin, they take a picture and write down where the ball finally lands.
That allowed us to make a very accurate measurement about the distribution of where the ball was landing and really understood how the ball was bouncing.
How's that?
It's beautiful. It looks just like Vegas.
But can they now take what they know about this specific wheel and use it to predict the outcome of a spin on any roulette wheel in any casino?
One thing you have to do is figure out certain fixed properties of a given table, and it might take dozens or hundreds of spins, gradually collecting data.
They discover that after observing any wheel for about 30 minutes, they have just enough data to determine those fixed properties. 4 variables which depend solely on the dealer. How fast he spins the central rotor, when he lets it go, when he throws the ball, and how fast he throws it.
If you click when 00 passes a fixed spot in the room and rotor, and if you click when the ball passes that same spot in the table, and when it passes that same spot in the table again.
From each specific targeted roulette wheel, Doan and Norman must collect this key information while the wheel is in play. Once they've determined the fixed properties, they're ready for the last and most challenging step. Applying the equations that will predict in which octant or eighth of the wheel the ball will land. But how can they work complex math equations in the middle of a casino?
To predict the path of the ball, we need to make hundreds of computations in a few seconds. We're going to need a computer.
Doan and Norman must build their roulette predicting computer from scratch. And it must be portable and hidden from casino security. Though it's not illegal to use a computer device in casinos in 1975, playing with an advantage means playing with fire.
We were a lot more worried about the practical effects of dealing with the mafia and the casinos than we were worried about the legality.
Despite their fears, Doan and Norman forge ahead. Doan writing a computer program that can predict roulette, and Norman designing a system for inputting and exporting the data. But how can they build a computer that will go undetected in a casino?
We decided to run wires down to shoes, and then in the sole of the shoes embed a little micro switch and have that micro switch actuated by big toes.
And once the clandestine computer made its calculations, how could it tell the player where to place the bet?
And we went through all kinds of ideas.
Send data to tiny speakers in their ears. Transmit radio signals to a van parked outside the casino. Or what about electric shocks?
Anything yet?
We had got little patches from places that were doing psychology experiments and tried administering these shocks in a controlled way.
How about now? Say when.
Oddly enough, the best solution is an electromagnetic device used in everything from cars to vending machines. It's called a solenoid.
A solenoid.
A metal plate mounted with solenoids would relay predictions to the player through distinct thumping patterns against their skin. Securing the vibrating solenoids in place requires creative jerry-rigging.
Better? We're in business.
As Doan and Norman overcome their technological hurdles, they must also design a plan of attack. It was slow going, and time is passing by. With their dream of a scientific utopia, riding on the success of a system for predicting roulette, Doan and Norman are finally prepared to risk it all in Las Vegas. They've spent almost 2 years and their life savings getting to this point, testing their scheme along with a hidden computer in a real Vegas casino.
The computer and the batteries typically went under the arm. Then another set of wires went down hands, legs to the shoes, to the toes.
Once he's picked a table, Doan plays low-stakes roulette. But what he's really doing is using the toe switches hidden in his shoe. Entering preliminary data about the wheel into the computer he's wearing around his chest.
They had a roulette wheel that nice tilt, and they were spinning the center wheel nice and slowly.
Now that he's entered enough data, Doan is ready for the real play. As the croupier spins the ball, Doan has about 15 seconds to make it all happen. Take the final measurements, 2 clicks for the wheel, 2 clicks for the ball. Wait for the computer to tap back its instructions. And then finally, place his bets.
You can just feel it, just thumping against your skin.
At times, the system encounters statistical fluctuations.
You can predict a certain octane and place your bet number in that octane and have it land right next to the number that you're betting on.
But over time, it gives Doan an enormous advantage. 44% to be exact. For every dollar he bets, he wins $1.44.
There's a tremendous rush of excitement to feel the chips piling up and really feel everything working.
Yes. Nice one.
Well, gentlemen, once again, I was doing fantastically well. Congratulations, sir.
But before long, casino security is on to Doan's repeated wins. And just as the heat turns up, another problem kicks in.
I was periodically getting shocks from the system. I was sweating a lot, and that's one of the reasons I was getting the shocks.
Are you okay?
Sorry. I'm sorry.
All right, sir. Good night.
These shocks were just driving me crazy. I knew that I was in trouble here when the pit boss came in. I had to sit there, of course, making sure I wasn't fiddling with the connectors coming out of my socks, where you could see me under the stall.
Doan and the pit boss begin a waiting game until
Pit 6, you there?
Pit 6 coming.
Can you check out a possible counter on PJ 12?
I'm on my way.
a narrow escape. But for Doan and Norman, it's a tremendous victory. The winnings may be unimpressive, but the actual value is incalculable. Proof that their system works.
We thought we were going to make millions.
And if the technology were really deployed with multiple teams and multiple
They are ready to enlist fellow renegade scientists in a life-changing venture.
It seemed to just attract people. Altogether, there were about 30 people involved in the project.
What up?
There are 2 players on each team, the data taker and the better.
The first recruits are the brightest stars on campus, including a classical pianist turned physics student named Ingrid Herman.
Bill is a salesman. He's so enthusiastic, and he gives you this weird self-confidence and sense of adventure when you're around him.
The whole time he or she is there, they're collecting data on this wheel. The rate of the ball's speed and deceleration, and the rotor's relative speed. Now, once the processor has received enough data to work with from this wheel, it can start to make accurate predictions. That's when the data taker calls in the better.
So the computer can predict exactly which pocket the ball is going to land in?
No. That's why we'll be betting on optics. See, the computer has shown us the best results at predicting which gates in the wheel or the octave the ball lands in. Now, each octave has 4 to 5 numbers, and we'll probably be betting on all 5 numbers.
But won't that give us away?
Not at all. Observe. If the computer gives us this octave, the numbers will be 4, 16, 33, 21, and 6. But if you look at it on the betting layout, it looks completely random.
And what if we get caught?
The system is perfectly legal. There's nothing against it on the books.
I mean, you couldn't have found a more ignorant bunch of people about casinos. None of us were casino people.
Computers like these, casinos don't even know they exist. Welcome to the ultimate physics experiment.
Their goal is to strike Las Vegas over summer vacation. But first, they've got to build more computers and train.
The whole foot keeps moving.
Just your toe, just your toe.
It's got to be instinctive. The fantasy was to live sort of undercover.
And I'll go here, here, and then here. Like playing Rachmaninoff.
Yeah, but this is hard.
The way this Roulette project has brought people together, that's the power of science. Not to destroy, to create, to invent, to unite. Together, I truly believe we can accomplish anything.
It's time for the Eudaimons to hit Las Vegas.
It was totally outside our society's normal system, and it was going to beat these big, rich, bad guy casinos at their own game right under their nose.
The battle is on. Rookie gamblers with a brilliant scheme versus brutal casino security, ready to break anyone with an edge. Now it's time for them to launch their attack.
Sin City, the neon beast. Terrifying, and yet beautiful. And now it's time to bring it down.
As we were getting out of the car to go into the casinos, there's always a bit of adrenaline rush because you're actually going into the battlefield, as it were.
The war against roulette begins quietly. No one suspects these students of having a secret advantage. Joan and Norman assume the role of data taker. As soon as they've gathered enough information for the computer to start making predictions, the team play begins. Ingrid and the others are bettors.
If the data taker bet on each.
Hello there. Lovely lady, pretty in pink. Best of luck, ma'am.
All right, make me rich. Come on, Mama.
The bettor's objective is to receive the predictions Lay down the big bets.
Oh, so close.
And keep cool.
The number is 35, black and odd.
I had a good feeling about you.
Congratulations.
It's like playing music.
Feel things click into place on about $600 in an hour and a half or 2 hours with $1 or $2 bets, and it was such a good feeling.
Oh my god, I told you. Oh my god, I keep it straight. Oh my god. Yeah, those computers are power.
Let you know, we did it. Physics beat roulette. We beat roulette.
Doan and Norman's teams begin using their system in casinos across Las Vegas.
Everything I know is in this. Every physics formula, every law of nature, every logic trick. Doesn't keep the wires from breaking. Or the radio from failing. And burn. We beat it, you know that? The random forces of the universe. Yeah. Where's our fame and fortune?
After 3 years devoted to beating roulette, Doan and Norman agreed to do the unthinkable, to disband the team, to let the project go. Although they must give up their dream of creating a retreat for the pursuit of pure science, they proved without a doubt that physics can beat roulette.
This is how you play roulette with all the numbers next to each other, because this system works. This isn't even really a system, this is common sense. You're playing every single number in that quadrant, and you're playing 12 numbers only. If you guys at work want to come up and ask me about it, I'll be glad to talk to you about it. I love talking about roulette, and many times YouTube wipes this video off my channel because they don't like it, so they get video wiped off my channels. Suggest you download this video to keep this information. Have a great day, guys.